All right. Well, thank you, everybody. I'm Saurabh Kapoor. I'm from Dell Technologies. I lead product management strategy for network software solutions and partnerships, along with the AI connectivity strategy. So that's new on the charter. This is my second year here. Fantastic work by Dan, Ashay, and team. So Gautam, Didipaya, and everybody, all the rock stars who've put this together. I think SONiC is one DNA that ties everything together, and it's great to see the turnaround here. I'm going to talk about a bunch of things here. We'll talk about SONiC as a technology, a little bit about the journey, the evolution. We'll talk about AI, how is that influencing our ecosystem infrastructure purchases today, and then we'll touch upon the industry trends in a little bit in that direction. So from the agenda perspective, we'll talk about what is Dell doing from infrastructure, compute storage, networking perspective, how we are evolving the AI landscape overall. We'll talk about AI, how is that different, from a technology perspective in terms of influencing the networking capabilities and the requirement generally? How is SONiC evolving into the AI ecosystem? Dave mentioned a little bit in that direction as the AI work group gets set up in the technical steering committee, and all the activities happening around there in terms of software capabilities. We'll talk about a little bit in the Ultra Ethernet Consortium Forum as well. And then finally lead into the way where we talk about some of the work that we have done in terms of proving Ethernet as a technology, and how is that going to champion the AI infrastructure overall. So I'll start with this. This is something we're very proud of. So Dell has been recognized by Forrester as one of the top leaders in the category of AI infrastructure, and that's an influence of a bunch of things. So one is our ability to offer choice, flexibility in terms of the compute ecosystem. So we partner with NVIDIA, Intel, and AMD to build compute platforms that are necessary for AI infrastructure. The ability to bring those compute infrastructure technologies into the existing ecosystems, the cloud service providers who are evolving themselves into AI as a service providers, and enterprise market taking the ride of AI. So sourcing technologies and infrastructures in that direction, and bringing choice and flexibility in that capability. The other thing is our ability to bring the marriage of the infrastructure from compute, storage, and networking together to create validated architectures. So for AI, performance is very key overall, right? And bringing the marriage of these products together to create a validated reference architecture that the users can quickly refer to and build infrastructures on top is something that is very differentiated and important. So we're very focused from a strategy perspective to build those capabilities together and offer that validated reference architecture to our customers. The third element that Forrester recognized was our ability to source in the technology in time, right? Because in times like now where AI is a big wave, influencing how the customers or the users are set up today, the timeliness of delivering the technology is as important as the technology itself. So very much behind it to make sure that we understand the market demands and help our customers get the latest and greatest in that direction. And finally, the choice of technology from a networking perspective. And networking is a very important topic, and I'll touch upon that in the later half here. We look at the world right now, it's evolving very quickly. Think of millions of devices teaming through the ecosystem around us, the traffic lights optimized based on the traffic flow. We're looking at buildings which are optimized now to adjust the lighting based on the user occupancy. Hospitals bringing in generative AI into their ecosystem in terms of running those predictive analytics and those predictions, right? And all of that is championed through networking as a technology that allows the movement of that data and packets across infrastructure, right? You need to get your networking right in order to fuel that ecosystem and to process that data and then source it to the applications for inferencing. So, bringing that choice of networking capability to enable that is something that is differentiated, and we'll talk about more on that in the later half here. So some of the use cases that we have seen across our user base is ranging from different functions, right? AI as a technology has been there for a while, but it was more around different centers of competence running analytics and financial groups and things like that. But today, as AI evolves from the traditional AI to generative AI, where you're using data to run analytics, you're running AI to process text, graphics, images, videos, and whatnot, is something that is very differentiated. So variety of use cases that we see, from different, business functions impacted by the usability of this technology is something that is evolving every day. The workloads, right? So it's very important to understand what kind of workloads are we going to see in the different user groups, right? So we have categorized that into three, buckets here. The training workloads, these are, environments that are running, workloads, for days and weeks. These are models, which are huge. The infrastructure requirements are very, very significant. Here, looking at thousands of GPUs, connected together. As you move towards right, you're looking at fine tuning as another workload where, this is like, fine tuning your models to make it more custom, make it more specific for enterprise consumption. And here you're looking at slightly lower scale, but you're still in hundreds of GPU from a network perspective, right? And then as you, shift right, this is where, as you're moving from, the building blocks or the building the AI models to more consumers of AI models, this is where enterprises come into play, and we're seeing a significant movement of, workloads in that direction as we get into, the later half of this decade as we go into 2029 and 2030. So a lot of movement happening here from an inferencing perspective. Now you're looking at more CPU-like workloads. The infrastructure requirements are not that, expensive as compared to the training and fine tuning, and then these are least demanding of the workloads from a fabric perspective. This is our dissection of our AI compute platform. We branded Dell XE9680. This is where we bring the choice of GPU technology from NVIDIA, AMD, and later half with the Intel. You're looking at different connectivity. Now, AI is distributed across three pockets, I say. The backend connectivity, this is your AI, backend connectivity, the choice of technology from InfiniBand to now Ethernet with high-radix switching coming into play there. Your front end is your storage and application connectivity. This is where, you've seen the traditional workloads across the pockets. And then finally, the third pocket is the out-of-band management use case, where you get access into the network, access into the fabric and set up the environment overall. So three pockets of connectivity: your backend, the GPU to GPU connectivity, front end, we call it the storage and application connectivity, and then the management or out-of-band management use case overall. Ethernet InfiniBand, right? This has been a hot topic, for a while now. And, the way we see the industry is like InfiniBand has been a great technology. It has championed HPC and AI use cases all these years, and we continue to see a lot of trend in that direction where, especially the ones, the larger players, GPU farms or AI factories, they continue to, go in the direction of InfiniBand, building those ecosystems. However, Ethernet is coming fast from a technology capability perspective. We see a lot of innovation happening in that space. In different forums like Ultra Ethernet Consortium, which are, where we have specific, work groups set up from storage to link layer and things like that to champion Ethernet as technology and take it forward for HPC and AI use case. So you see a lot of, innovation happen in Ethernet. And Ethernet as a technology, some say it's like 50 years old. We say it's 50 years young. Every 18 months to 24 months, you see the speeds double. The amount of innovation or, the cost of building infrastructure with Ethernet is significantly advantageous. And you see a very commodity market. So there's so many players. So it's more community, more collaboration, and more cooperation, as I say, in terms of, taking it forward. So Ethernet is coming very fast from a technology perspective. We start to see a lot of AI factories now looking at Ethernet as a technology to build those AI infrastructure, as we see the likes of 800 gig and 1.6 terabyte on the horizon now from a technology build-out perspective. So a lot of innovation expected in that category. Now, while we're championing Ethernet, right, there's a lot of innovation happening in the network operating system world as well. Because the software is where the innovation is key, and AI optimized capabilities making its way into network operating system championed on Ethernet is one big fundamental aha moment that is happening in the industry. So a lot of activity happening there. One thing it's often underrated. We see the automation monitoring aspect of these capabilities. With Ethernet, you get more choice, you get more flexibility with respect to how you want to build your infrastructure, right? The choice of automation, be it using, Ansible-like automation tools or third-party enterprise tools, with multi-vendor management capabilities, multi-vendor monitoring capabilities is something that is very differentiated. So with Ethernet, the trend is happening now. It's a lot of innovation happening, and we expect that in the next 18 months or so, we'll have some really cool, references that enterprises can refer to in terms of building those AI infrastructures there. Talking about references, right? So here are some snapshots, looking at different, users who have gone about using Ethernet as a technology to champion and build AI fabrics. And these are all, public studies. I've got a bunch of links embedded here in the PPT, where they've gone about, and some of those actually have gone about in using SONiC as a technology to champion that environment. So, these are great proof points. I think these are like, the ones, the early starters in that category of, using Ethernet as a technology for AI fabrics. And we're seeing a lot of users now running proof of concepts and looking at, those models and the performance optimizations, fine tuning those AI fabrics, et cetera, with Ethernet. So, very much behind that momentum. Now, bringing it all together, I touched upon this topic a little bit earlier, right? So in the world of AI, we're looking at, again, three pockets, back end, front end, and an out-of-band management. Now, Ethernet as a technology has the ability to tie all of these things together in one unified fashion. And this is very differentiated and unique in the capacity where, having one technology that extends out from back end, front end to out-of-band management simplifies the day zero to day two management, right? You can have one common operating system with, underlying Ethernet as a technology run across the board, same set of tools that are managing these fabrics together, simplifies the whole lot of, usability and the lifecycle management experience. So in that front, I'm going to shift gears and a little bit talk about SONiC and how that has been evolved and where are we kind of with the community taking it forward to champion, our users with Ethernet and SONiC. And this is, the force around simplifying the usability and the infrastructure for AI fabrics. And when we look at these environments, we touched upon, different workloads, et cetera, but here are some key characteristics of AI fabrics, right? So you're looking at the capacity and latency requirements here. So these are data-intensive use cases. Here you require high radix switching, non-blocking architectures, instead of your traditional latency-specific requirements that are important for HPC use case. For generative AI, it's more about tail latency and the job completion time. You're looking at lossless networks where, you cannot afford to, lose packets. You're running training models that run from days to weeks. And, you need lossless fabrics to improve that. When you look at the network operating system, you need high sustained traffic, you need better load management, you need to manage entropy, you need to have better visibility in the fabrics. Why? Because you're running these fabrics at peak performance all throughout, right? It's not like, you're fluctuating on the bandwidth. These are running at peak capacity all the time. So better telemetry into the fabric allows you to take more predictive actions as opposed to your standard reactive, SNMPs and syslogs, right? You need more visibility into the fabric all the way into the silicon level to look at what's happening at the buffer level, the buffer statistics and the likes of those to be able to manage these fabrics, better. And then finally, multi-tenancy. That's where Ethernet shines, right? Ability, and especially with these CSPs who are building AI as a service models where they're hosting different kind of workloads, different kind of users on the same fabric. Ethernet as a technology allows you to have multi-tenancy setup, setting up different tenants, on the same infrastructure, and based on how you want to set up those environments, you can, allocate times. And, often I've seen, these kind of coming down to GPU per second kind of a consumption model for their end users, right? And finally, management and orchestration, right? I touched upon that a little bit earlier. This is one area where, a lot of focus, R&D, and investments are going to happen across the industry. Right? For AI fabrics, the management and operations are going to be a very important topic. And then there was a study that was done by Meta a couple of years back at OCP, and they presented Alexis and team, where they showed that, an amount of time package spent in AI fabric is more than 50% in networking. So you need to have your networking done right. You need to have that visibility in the fabric. If you don't have your networking done right, then you won't be able to take advantage of all the great things that are, set up from a compute perspective. So how are we approaching this? We are approaching this as a solution, capability. So as opposed to looking at, from product perspective, what's doing, AI compute platforms or storage or networking, we're bringing the marriage of the technologies together to create validated reference architectures. So from a Dell perspective, accelerated AI, energy efficient platforms, you're looking at flexible architectures, choice of GPU, from a solution perspective, you're looking at high performance, low latency fabrics, looking at high radix switching all the way from 51.2 terabyte it's available in shipping right now, and then championed it all together with open standards, open architectures with SONiC. So SONiC is the underlying vehicle for innovation at Dell. We're doing a lot of investments in championing SONiC across new and emerging use cases. So last year I talked about how we extended SONiC from data center to branch edge use cases. This year I'm focusing more on AI fabrics, on what we have done in that capacity, and I'll touch upon some of the key features that we have brought in that category. And then intelligent orchestration and solution capabilities. So this is where innovation lies, collaborating with niche players in the industry. We've gone about, building these suite of automation monitoring tools to bring that, niche capability of managing multi-vendor solutions, and then SONiC as well, from a management and operations perspective. So here we talk about SONiC and then what has happened in SONiC over the last 12, 18 months in terms of enabling it for the AI use cases. And we've got a bunch of great users who have championed this technology with Ethernet and SONiC into their AI fabrics and running some really good results that we have, I'm going to touch upon there. Adaptive routing, our ability to run dynamic load balancing, finding the most optimal link to deliver performance and capabilities, bringing in advanced hashing capabilities to address the entropy specific use cases, enabling the RoCE capabilities with priority flow control, explicit congestion notification capabilities, better telemetry, telemetry all the way from the silicon to the network operating systems consumed in different applications, and then finally bringing multi-tenancy capabilities, right? We recently announced Tomahawk 5, the 800 gig platform, bringing multi-tenancy capabilities and exposing that, through SONiC for AI fabrics. So these are some of the key AI optimizations that have happened over time, and then we're looking to expand that into likes of weighted ECMP and other capabilities that are going to roll out later half in the year. So a lot of innovation happening here, and then we're working with the community. There's an AI work group that is set up in the SONiC TSC group, where likes of us, NVIDIA, Broadcom, everybody's coming together to collaborate, innovate, and see what else is needed to champion SONiC for these AI use cases. And it's very important. I mean, this is where the contribution, collaboration is fundamental here, because all the vendors, from silicon vendors to ODM and OEMs in different application vendors, we can find a common ground here to share our experience, to share our user stories, and see what else is needed to champion SONiC and make it available for the broader community overall. Here are some reference recommendations in terms of our journey and enabling some users expand and build AI infrastructures. These are some of the the fabric scales we have seen. So for a single switch, you're able to set up 128 GPU clusters. You're with a 2-tier rail optimized topology. This you're able to achieve up to 8K GPU clusters, and then finally all the way up to 50K GPU clusters in a 3-tier architecture. So those are some of the scenarios or use cases that we have validated across our labs, and some common across some user base who've gone about in production. We've also expanded on that in different bandwidth domains, and seeing on how in a single fabric or a pure rail optimized designs with different hubs, different pods, what are different scenarios and scalability numbers you can achieve, and these are all available here. What we've also done is look at the layout and the physical considerations, right? What are some of the considerations from a power and rack management systems, right? So we're looking at our typical XC96 80 chassis is around 1,000 millimeters, and you're looking at filling up all the way up to 1,200 millimeter from a rack density perspective. Looking at chassis that are 19-inch racks. There are conversations with users who understand what they're doing from a 21-inch rack perspective. From a weight management perspective, we've shared some guidance. There are best practices that we have published for these customers who've gone about setting up their infrastructure. From a power consumption perspective, we're looking at around 12 kilowatt per AI server, and obviously these are infrastructures that are very power hungry. So we're looking at how do you optimize that? What are the capabilities to reduce the power consumption and still make it more optimal and performance fine-tuned, right, overall. Cooling is one some important an aspect here. So looking at what are the key technologies that we can follow and champion to improve the cooling and the power consumption of these data centers. We've also looked at validating and using third-party, ecosystems to validate the performance numbers. So this is one of the use cases that we had for an enterprise customer, a communication enterprise customer, who went about, deploying Ethernet with SONiC for their AI fabric for their, fine-tuning use cases. And we went about, with Tolly to validate some of the performance results, right? And, the numbers are very impressive, right? There was always a discussion around InfiniBand and versus Ethernet in that category, and Ethernet is performing as good as InfiniBand in that space, right? So we got about, getting a perf test of 391, GPS. This is 100 gig Z9664 platform that we had, set up in that environment. So very impressive numbers. Node to node nickel throughput was 390 gig. This is a setup with NVIDIA H100. Connected with NVIDIA CX7 NIC solutions with our Tomahawk 4 switches running SONiC in a real optimized topology. So it's a public study. We published that and made it available. The link is referenced here. We're doing a lot of these performance validation and reporting. We've published some white papers recently with AMD platforms, and we'll continue to roll more and more of these solution validations as different architectures for users to go about and champion their environments. This is one of the proof points. So a lot of these, are available and a lot more coming in that space. From a thought leadership perspective to technical resources, reference points. We're also looking to bring in a few users who've gone about, championing their environment with these technologies and what are the best practices overall. And then probably so Dell IT, one of the largest IT networks in the world, is also running SONiC. We have, SONiC running across both, AI and non-AI workloads. We have around 1,000 switches that are in production already. We're looking all the way up to 15,000 switches in the next 18 months, in production with SONiC. We're going to do a case study and talk about some of the best practices that Dell IT followed. And Dell IT, as you can imagine, these are different enterprise applications that we are running across the board, the manufacturing sites. These are branch offices, customer solution centers, executive briefing centers. So imagine the landscape from data center to all these edge locations, powered by one unified network operating system. And this is, taking them from, one of the proprietary stacks to more open architectures, and they've, all good things to talk about and share on the SONiC side. So please look out for the case study and a video testimonial that we're going to publish soon, and it'll be also hosted on the Linux Foundation umbrella. Finally, and this is where I'm going to wrap it up here. These are platforms for contribution, collaboration, and enabling that plethora of innovation, right? So SONiC is once in landscape. The governing board is very, very engaged to champion SONiC, to increase more adoption of SONiC. Sponsoring events like that, enabling that. The technical steering committee and outreach committees are focused to enable everybody. Thank you, Ashay and team, for bringing this together. Now we also have Ultra Ethernet Consortium to champion Ethernet for AI use cases. So a lot of activity happening there. More and more collaboration leads to more innovation. And the key takeaways are, networking is extremely important, right? We're looking at all these use cases, and getting the networking right is very critical, very important to take the best advantage of these powerful compute platforms to bring innovation there. Ethernet is the future of AI, and very much behind it from an industry perspective to champion it. And then finally, we'll continue to innovate, build validated reference architectures, and make it available as reference points for people who want to champion AI in their environments with Ethernet. So with that, thank you all. Open for any questions here.
Thanks a lot, Saurabh. If there's any question, I would like to pass the mic. Okay, if not, that's good.
All right, perfect. Everybody's ready for the break.
I think we have one question.
There was a question?
I'm Sachin from Broadcom. Towards the end, you mentioned that Dell is planning to deploy SONiC in IT,
Yes.
the IT network, right?
Yes.
So apart from data center, you guys are also deploying into campus.
Yes.
So are you planning to deploy the .1x pack features there?
Yes, yes. So we already have SONiC in production, by the way, across both data centers and some campus locations. We are using power over Ethernet and port security for some of those environments. So we have our own suite of edge switching, as we say. They run up to 90 watt power per port, and a lot of these use cases require think of IP turrets and security cameras and different environments that we have set up from our customer solution centers as well as the branch offices. So those are already in production, and they're running those capabilities. So .1x and PoE would be the two features that we're using.
Okay. So right now the scale is around 1,000 switches, and you guys plan to?
Yes. So today we are production around 1,000 switches, and then pre-prod and POC is all the way up to 18,000 switches in the next 18 months.
Great. Yeah. Thanks.
Yeah.
Yes.
A nice talk. Thanks for the talk. Any plans to upstream this to the community? What are features you talked about?
Yes. So we are proudly so one of the top contributors to SONiC. And all of the capabilities that we have talked about, we have a goal of 100% code contribution. It usually spans from a feature showing up on the Dell commercial release to making it back into the community in about 12 to 18 months based on the code reviews and what community release it gets stacked to. But 100% of our code will be back into the community.
Okay. Oh, thanks.
Any other question? All right. Thank you all.
Cool. Thanks a lot. Thanks a lot, Saurabh. So we will take like 10-minute break. If anybody would like to have some tea and coffee, there is a pantry nearby. Let's do that. And in 10 minutes, we will start with the next presentation with Marvel. Thanks a lot, everyone. Thank you. Hey, just to let everybody know, the plastic bottles we are using for water, please use to dispose that within a room. We have one garbage bag on the right side and one on the left side. Please do not throw that outside. And everyone who came late, please collect t-shirt, tag, especially